So good evening and welcome to my class on GER Hub. Today we are going to be discussing problem solving in indices. So this will be our fourth class or third class on indices, which rounds up everything. I think this should be the third class. So today we shall be discussing problem solving in indices. So in my first class with you guys, I had discussed indices in terms of what it is. I've discussed so many other aspects of the topic indices. I had discussed that with you guys, and in the second class precisely, I had to go through the proof of all the laws of indices. So in this video, what I shall be doing will be to solve problems in indices. So let's start with the first problem. If you were given a problem like this, to solve this, that is to simplify this, 7x times 3x raised to power minus 2. The question is, using the laws of indices, how would you simplify this? Now to do this, I would simply say 7 times x times 3 times x raised to power minus 2. Okay? Now what I'm going to do next is to take to do a little bit of grouping. I'm going to do a little bit of grouping. So I'm going to take these to themselves, and I'm going to take these in product to themselves. So I'm going to say, by rearrangement, 7 times 3, put in one bracket, times, in another bracket, x times x raised to power minus 2. Now 7 times 3 is 21, times x raised to power minus 1. I'm going to write this as x raised to power 1 times x raised to power minus 2, So by the laws of indices, this becomes x raised to power 1 plus minus 2 by the addition law. And that would mean 21 times x raised to power 1 plus minus 2. Plus times minus is minus, so this becomes 1 minus 2, and you end up having 21 times x raised to power minus 1, okay? Which is supposed to be 21 times, by the law of negative index. By the law of negative index, the law we actually applied here in the problem was this law, a raised to power x times a raised to power y equals a raised to power x plus y. That was the law we applied at this point. At this point, the law you are going to be applying will be this law. A raised to power minus x is equal to 1 all over a raised to power x. So you'll be applying this law at this point. So that would make us have 1 over x raised to power 1, which is the same as 21 times 1 over x. And 21 times 1 over x is just like 21 over 1 times 1 over x. 21 times 1 is 21, and this will be 1 times x is x. So this simplifies the problem for you, and that solves that problem. Now let's move over to the next problem in this class. The next problem I would want us to look at, still on applying the laws of indices, is the next one here. So I have 2p. You're asked to simplify this. 2p 4p raised to power 2, all together raised to power 3, times 3p and what do you call it, q raised to power 2, okay, q raised to power 3 all squared. So you're asked to simplify this. The question is, what would your result become? So let's take this as problem number 2. So if you are given a problem like this to simplify, what would you do? Now please take note, like we did earlier on, I could start with expanding. Now look at this. I would use the law, I would apply to this part the law of shared powers. AB raised to power x equals a raised to power x, b raised to power x. That is the law I'm going to apply here. So if I do that, I'm going to have 2 raised to power 3, p raised to power 4 squared and I'm going to have p raised to power 2 raised to power 3. Okay, so this should be 3. Okay, now, so what I have just done is using this law of shared powers. If there is a power outside this bracket comprising two numbers or more, then each of them will carry the power, just like 2 is carrying 3 as power. Okay, p raised to power 4 is carrying 3 as power, p raised to power 2 is also carrying 3 as its power. Then I would come over here and use the law of shared powers again. So 3 would carry this squared, I'll put it here. This p here will carry this squared, I'll put it again. Q raised to power 3 will carry the squared there. So that is what we are going to have. Now let's simplify further. Here I'm going to have 2 raised to power 3 is 8. Okay, now p raised to power 4, the law of shared powers has been applied already. Now let's look at the law of powers. Remember this law, a raised to power x times y is equal to a raised to power xy. So all you have to do is to multiply 4 times 3. So that will be p raised to power 12. And this will be 2 times 3, which this will be p raised to power 6 times 3 squared is 9. P squared is what you have here. And q raised to power 3 times 2 will be q raised to power 6. Now, I'm going to say 8 times 9 in one bracket, the two numbers, this number, that is this number, and this number. Both of them are numbers, so I'm going to multiply them. Then the next one I'm going to take is the p's. So p raised to power 12 times p raised to power 6 times p raised to power 2. I'm going to put it in one bracket. Then times q raised to power 6. So this will give us 8 times 9 is 72. Okay, so I'm going to put 72 here times, okay, p raised to power 12 times p raised to power 6 times p raised to power 2 by the addition law of indices will mean, since they are all the same base, this will be p raised to power 12 plus 6 plus 2, and that will give you what we have there, times q raised to power 6. So this will be 72 times p raised to power 12 plus 6 plus 2. This is 6 plus 2 is 8, 8 plus 12 is 20, so this will be p raised to power 20 times q raised to power 6. So you could just merge your answer as 72 p raised to power 20 q raised to power 6, and this will be the simplified result. Now, so I would want you to go over this again and see how that was done. Let's go to number 3. For number 3, we have 11d raised to power 3 e times 4d squared e raised to power minus 3. Okay, so we are asked to simplify these. So how do we simplify? I'm going to take numbers to numbers, that is like terms. So 11 times 4, I'll take in one bracket times d raised to power 3 times d raised to power 2. I'll take in another bracket times, I'll take e raised to power e times e raised to power minus 3 in one bracket. So that is what I'll do. And this will now give me 11 times 4 is 44 times d raised to power 3 plus 2 by the addition law of indices. Then e raised to power 1 times e raised to power minus 3. Remember we said by that law of unity that e raised to power 1 is e. So instead of writing e, I will just put e raised to power 1 so that it becomes very clear what I want to do there. So this will be 44 times d raised to power 3 plus 2, okay, times e raised to power 1 plus minus 3. And that would now amount to 44 times d raised to power 5 times e raised to power 1 plus minus 3. Plus times minus is minus, so this will be minus 3. So you end up having 44 d raised to power 5 e raised to power minus 2. Now, take note, by the law of negative index, this can be transformed to becoming 44 d raised to power 5 all over e squared, because e raised to power minus 2 is equal to 1 over e squared. So that is what you are going to have. Okay, so this will be your final answer. Now, so go over it again. Let's now move over to the next problem. number 4. So for number 4, we are asked to simplify 5d raised to the power 3 over 2, okay, times 2e raised to the power minus 7 over 2. So let me put this as d. So we are asked to simplify this 5d raised to the power 3 over 2 times 2d raised to the power minus 7 over 2. So what would you have? Now I will take numbers to numbers. 5 times 2 in one bracket times d raised to the power 3 over 2 times d raised to the power minus 7 over 2. So that's what I'm going to do. Now the next thing I'm going to do is 5 times 2 gives me 10 times, by the addition law, 3 over 2 plus minus 7 over 2 is what I'm going to have here. So 10, since they are the same base, the addition law applies. So this will be 10 times d raised to the power 3 over 2. Plus times minus is minus, so I'm going to have minus 7 over 2. Now this will be 10 times d raised to the power. The addition of these two, the LCM is 2. Okay, so the LCM is 2. The LCM of 2 and 2 is 2. 2 in 2 gives you 1. 1 times 3 is 3. 2 in 2 gives you 1. 1 times 7 is 7. So minus 7 is 7. So you end up having 10 times d raised to the power 3 minus 7 will give you minus 4. So this is minus 4 over 2. And that simplifies again to 10 times d raised to the power minus 4 over 2 gives you minus 2. Okay, so again by the law of negative index, this would give you 1 over d squared. Okay, so this gives you 10 over 1 times 1 over d squared, and your answer becomes 10 times 1. 10 times 1 is 10, and 1 times d squared is d squared, and this will be your final result. So go over it again, and please drop your comments or questions in the comment section. Let's go to number 5. Now for number 5, we have 16 v cubed times 2 v squared all raised to the power minus 3. Now that will give you 16 times v cubed times, now if you apply the law of shared powers here, this will be 2 raised to the power minus 3, 2 carrying this power outside, and v squared raised to the power minus 3. So that's what you're going to have. And this will be 16 times v cubed times 2 raised to the power minus 3 times, by the law of powers of powers, these two powers will multiply. So you end up having v raised to the power minus 6. Now, I'm going to take numbers to numbers. So this will be 6 times 2 raised to the power minus 3 times v cubed times v raised to the power minus 6. So by simplifying this, I would have 16 times, this is 1 over 2 raised to the power 3 by the law of negative index, and times v over 3, and v cubed rather, by the addition law, you would have this. So 16 over 8 is what you're going to have, because 2 raised to the power 3 is 8. 8 cancels these to give you 2. So I'm going to write down my 2 there. Times v raised to the power 3 minus 6 is v raised to the power minus 3. And that will be times 1 over v raised to the power 3. Because by the law of negative index, that is true. And this will be 2 times 1, 2. V cubed times 1 is v cubed. So this will be your final result. Okay? Now, let's move over to question number 6. For question number 6, we have a problem of this nature. We are asked to solve this problem. Okay? So this problem comes from what we call indicial equations, and I'm going to be treating that in my next class, my next video. I'm going to be treating that, even though I'm going to be solving more problems on that. Let's just take this problem for instance. So how do you solve indicial equations? The simple truth in solving indicial equations is to reduce both sides to the same base. Okay, reduce both sides of an indicial equation to the same base and equate their powers. After doing that. That's just all. It's very simple. So now looking at this, the answer to this problem will be x equals 0. Now, the law of initial equation requires you to put the two numbers on both sides of the equation in the same base. Looking at this is 2, the base on the left hand side, this is 2, the base on the right hand side, carrying x here on the left hand side and carrying 0 on the right hand side. Now, if the two bases are the same, then the powers are automatically equal. So x is equal to 0, and that solves that problem. For number 7, please watch out for my video on initial equations. I'll be dropping that video tomorrow. Thank you very much. So this is 49 raised to power y equals 1 over 3, 4, 3. Okay, so let's see how we get that done. So let's see how we get that done. Now, like we said earlier on, the problem in initial equation remains simple. All you have to do is to reduce both sides to the same base. Okay? Once you can reduce both sides to the same base, you've solved that problem. So let's see how we get this particular problem solved. Let's see how we get that problem solved. So, looking at it, I'm going to do this. For this particular problem, I'm going to have 49y here. Okay, let's rather start with 49 can be written as 7 raised to power 2. So I'm going to put 7 raised to power 2 in place of 49. And on this side, I'm going to put 1 over 343 is 7 raised to power 3. So I'm going to have 7 raised to power 2y by the law of powers. The two powers will multiply. And this will be equal to 7 raised to power minus 3 by the law of negative index. Now, by the law of negative index, of course, this is true. So what I'm going to do next is, since I have satisfied that law for solving initial equations, that 7, both sides are of the same base, 7 and 7, then it means that their powers are equal. 2y will be equal to minus 3. Remember, if both sides can be reduced to the same base in an initial equation, then the powers are the same. So y will be equal to minus 3 over 2 if you divide both sides by 2. And once that is done, you end up having y to be equal to minus 3. So it is that simple to solve that initial equation. Let's look at problem number 8. So in problem number 8, there is another initial equation or exponential equation, or initial equation rather, that says 4 raised to power y minus 3 is equal to 64. So how do you solve this? Again, the problem still amounts to reducing both sides to the same base. So 4y raised to power 3 raised to power 4 raised to power y minus 3 equals 4 raised to power 3. 4 raised to power 3 is one exponential form of 64. So I'm going to write 64 as 4 raised to power 3, 4 times 4 times 4. Now, I have clearly reduced both sides to the same base. So it means that y raised to power y minus 3 will be equal to 3. If both sides are in the same base, then their powers are equal. So this will give me y equals 3 plus 3. And that will give me y equals 6. What did I do here? All you had to do was to add 3 to both sides. Okay? The essence of adding 3 to both sides was to make y stand alone. It is y I want. I don't want y minus 3. So if you want to eliminate minus 3 from this side, you have to add 3 to both sides. And that would mean this gives you 0 and this gives you 6. So y is equal to 6. That will be the solution to that initial equation. Now, the next problem I have is problem number 9. Let's go to problem number 9, guys. So for problem number 9, we have 2 raised to power z plus 2. 2 raised to power z plus 2 is equal to 0.125 in problem number 9. And we are asked to solve this initial equation. Okay, sorry about that. So this is what we are asked to solve. Now what would I do? 2 raised to power z plus 2 is equal to, I'm going to put this in fractional form. So in fractional form, this is 125 divided by, look at it carefully, 1 0 cancels, it moves the point one time. It cancels, it moves the point another time. It cancels, it moves the point here. So you have 0.125. So all I did was to reverse the process. So let's go over it again. So 2z plus 2 will be equal to 125 all over 1000. Okay, 1000. Now, once you've done that, the next thing to do is to simplify. So what am I going to do here? I'm going to see how I can divide. Okay, let's see how we can actually divide this. So 2 raised to the power z plus 2 will be equal to 25 can actually go into 125. 25 in 100 is 4, so 25 in 125 is 5. So this will be 5. 25 can actually go in this. 25 into 1000, this should be 40. Okay, so you have 40 times 5 giving you 40 times 25 giving you 5 times 40 will give you 200, and 2 times 40 will give you 80. So let's see. Okay, so that is correct. Now, so 5 again goes into itself 1, and 5 into 40 will give you 8. Now that will give me 2 raised to the power z plus 2 equals 1 over 8. Now this should give you 2 raised to the power z plus 2 equals 1 over, write 8 as a number in index form, that is 2 raised to the power 3. And I'm going to do this further. Z plus 2 equals 2 raised to the power minus 3. Okay, so that being done, you can now see that the bases are the same. Therefore, 7 plus 2, the power must be equal to minus 3. So if you eliminate 2 from this side by subtracting 2 from both sides, you are going to have z equals, of course this is 0, so you are going to have z equals minus 5. So that will be the solution to that problem. Okay, that will be the solution to that problem.